The question here is asking us to find the enthalpy change of the formation of ammonia using section 11 of the data booklet. So here I've already pasted section 11 for you, and these values are enthalpies of each individual bond. So for example, the bond enthalpy for a nitrogen to nitrogen bond is 945. Or if we look at a carbon to hydrogen bond is 414. So it's enthalpies for individual bonds. So let's break it down. So here is our question right here, the formation of ammonia. And let's look at it step by step. Let's look at nitrogen to nitrogen bond first. It is 945, and let's write that down here. Then let's move on to a hydrogen-hydrogen bond. Hydrogen to hydrogen is 436. But let's not forget the coefficient here. Because we have a coefficient of 3, we have to take 3 times 436. Then we have the nitrogen to hydrogen bond. Hydrogen to nitrogen bond, that is 391. And you have 3 hydrogens connected to nitrogen, so you have 3 hydrogens connected to nitrogen, so you have to take 391 times 3, and we don't forget our coefficient here too, so altogether we're taking 391 times 6. Now, to find the total enthalpy change, we have to use this equation here, bonds broken minus bonds formed. So bonds broken is on this side of the equation because you have to break the bonds between this and this first in order to produce ammonia. So bonds broken are exothermic. Remember, they're always exothermic, so they have a negative value. So let's draw a negative sign here and here. And bonds formed is obviously the ammonia, and it's endothermic, so it has a positive value. So now let's use this equation to find the total enthalpy change. So we take negative 945 plus negative 3 times 436. Okay, so this is your bonds broken. And you take that and you minus your bonds formed, so 6 times 391. And if you do the calculations, your final answer will be negative 93, which is also what you can see here. And do not forget your units, kilojoules. So there you have it, that's your answer.